So second example of finding area between two curves that don't intersect over the region we're looking at. So I want to find the area between H and G from 1 to 3. And again, I'm already telling you that they don't intersect, but graph the picture and check it. So my G of X is 1 over 2, my H of X is 2, find the area. So again, the first thing I do is go to my calculator, so I'm going to type them in, and I already did. I took 2 divided by X and 2e to the negative X, and so I'm going to hit graph. Alright, so there's the graph of my function. The blue function is the G of X, 2 over X. The red function is H of X. So again, this is my e to the negative, my 2e to the negative X is the red function. So the area I'm looking at is the area between 1 and 3. So this little bitty region here is the area I'm looking at. And so I'm going to kind of try to graph that in my notes. Alright, so the picture. So maybe I will use 2 different colors. Alright, so the blue function was my G of X. So G of X, which was 2 over X, which is this shape. My red function, which again I'm going to make it a little bigger than it really was. It's that E function that approaches So they actually, G of X is greater than H of X from 1 to 3. Actually, it's greater than H of X from 0 to infinity, and then it's smaller over here. Alright, so the part that we're interested in is between 1 and 3, which is roughly around here. So this is the little bit of area that we're looking at, the area between 1 and 3 of my function G of X and my function H of X. So again, remember H of X, the red function, which was 2e to the negative X. Alright, so there's the little bit of area that I'm looking for. Alright, so I know G of X is greater than H of X, so when I want to find the area, I'm going to integrate from 1 to 3, taking G of X and subtracting away H of X. Alright, so to find my area, I'm integrating from 1 to 3. I'm taking G of X, which is 2 over X, minus H of X, which is 2e, keep creating my 2e to the negative X. And in this case, I can't, like the previous example, I could simplify it. It came out to a nice, neat looking parabola. This one doesn't simplify, so it's just those two functions subtract. But when I go to solve it, because the way I have to solve it with the fundamental theorem of calculus, I'm going to graph that subtraction. And so just make sure when you're careful on your graphing calculator. Alright, so I'm going to go back to my graphing calculator. This is the function I'm going to graph, right? The function G minus H is what I'm graphing. Alright, so I'm going to go back in here. I'm going to clear out this one. Clear. I'm actually going to use the previous one because that's the first function, and then I subtract 2e to the negative x, right? 2 divided by x, 2e to the negative x. Graph. Right, so my new function, right, so there's just one function graphed here, and so that's the new function. Right, that blue line is the function 2 divided by x minus 2e to the negative x, and I'm looking for the area between 1 and 3. And so when it's regraphed, right, it's just this piece, and that's the only piece that exists. And then I'm looking for the area 1 to 3. So when we go shade that in, that's the area. This area, even though it's a different shape, and it is a different shape, that area is exactly the same size as this area. Alright? But I can solve this one using the fundamental theorem of calculus because it's against the x-axis. This one's not. I can't solve it using the fundamental. Remember, the fundamental theorem of calculus is the area between a curve and the x-axis. Well, this is an area that's above the curve. Alright, and below one curve and above another curve. And so in order to find that, I have to rewrite it so that I can use the fundamental. And so that's what's, again, kind of unique about this function. When I rewrite it, I can use the fundamental theorem of calculus. And it gives me a new shape, but the same size area. Alright, so I'm going to go to my calculator and I'm going to find it. So pop my calculator up here, hit second trace 7. Lower limit 1, upper limit 3, and it'll shade that little bit of area in. Comes out 1.561, and so that's what the area equals. So it's a very small area. That sure makes sense. The picture was very small. So the area equals 1.561. That's what this definite integral equals, right? That area, which is the same as this area. That area is 1.561. So again, it's very unique. It's a very fun and interesting thing that happens. All right. Again, it took a while to figure this out, way back when Sir Isaac Newton was doing this. But this is a very fun and interesting thing that has happened. So we know the area between. That's the area between f of x, not f of x, g of x. G of x and h of x over the interval 1 to 3. Alright, we'll stop there. We'll pick up the next example in the next